Today we'll be talking about two transformations, but right now my focus is dilation. Dilation means stretch or shrink. Now I am assuming that you already watched the first video about transformations, which is about translation, and that you are familiar with inside and outside of parentheses. So let's get to this. Here's an example of dilation. How do we know when there is a dilation? Now that means something must be multiplying or dividing in order for there to be some sort of dilation. So if I give you a generic function right here, f of x, and I change it to become a times f of x, this right here is multiplying to the function. Since it's multiplying, that means we have some sort of dilation. Now, if you remember from the last video, if you are outside the parentheses, that means it's a vertical change. So if once again, the same rule follows. If you're outside the parentheses, you have a vertical change. So I already know that this is a vertical dilation because you are multiplying. And I know specifically it's a vertical dilation because you're multiplying and you're outside the parentheses. Now, the only thing I need to figure out is it stretch or shrink. So, in this case, it depends on the number. If a is greater than 1, then I know that it is a stretch. Now, if a is greater than 0 but less than 1, then I know it is a shrink. So, for example, let me give you something more specific. What if f of x was square root of x? Then let me put a 3 in front. And what if it changes to 3 square root of x? This 3 is multiplying, therefore you know you have a dilation because you're not adding or subtracting, you are multiplying. Now, since this is outside the parentheses, and let me just emphasize where the parentheses is, the parentheses be right here. This 3 is outside the parentheses, and therefore we know it's a vertical change. Now, the only thing that we think about is what does this mean, stretch or shrink? Well, since 3 is greater than 1, I know it's a stretch. So this 3 right here means we have a vertical stretch. By 3. Now let me give you an example of shrinking. So a shrink happens if the number is between 0 and 1. So that must mean we can have a fraction of 2/3. As you can see, this time all I did was change the 3 to a different number, 2/3, which is a number between 0 and 1. So it is still outside the parentheses, and once again, just to emphasize, the parentheses, let me draw the parentheses for you right there. It's clearly outside the parentheses, so that means we have a vertical change. So I know this means we have a vertical change, and we know it's a dilation because it's multiplying. Now, what kind of dilation is it? And we know it's a shrink, because 2/3 once again is between 0 and 1. So it's a vertical shrink by 2/3. Now, let me show you a horizontal stretch or shrink then. Now, if you remember from the last video, a horizontal change happens when it's inside the parentheses, so we got to make something that happens inside the parentheses. So once again, what if I change f of x into f of a times x? As you can see, the a is multiplied to x. It is multiplied inside the parentheses. So if you're inside the parentheses, we know once again it's a horizontal change. Now, not only that, we must know that if you're inside the parentheses, the opposite happens. Just like in translation. Same rules. So, it's a little bit more complicated with this, because we have to think about the opposite of multiplication, which is really division. So it's a little bit more complicated. So let's be more specific with the numbers then. For example, what if I gave you f of x equals x squared? Oh no, let's continue with the same as before, square root of x. And let me change that to square root of 3 times x. As you can see, unlike the previous example, the 3 was outside the square root symbol, and this time the 3 is inside. And just to emphasize some more here, let's put the parentheses to make sure you understand that 3 is inside the parentheses. So two things will happen. It means that we have some sort of horizontal change. That 3 means we have a horizontal change. And since we are not adding or subtracting, but multiplying instead, we have some sort of dilation. But remember, the opposite happens. So instead of multiplying by 3, actually what happens is divide by 3. So if you're dividing by 3, it actually makes something smaller. So we know that we're inside, so it's horizontal. So this means that we have a horizontal. And that number 3, well, let's do the opposite of times 3. Once again, means divide by 3. Or, if you do the reciprocal, it means multiplying by 1/3, which is the opposite of times 3. So 1/3 is between 0 and 1, therefore it is a shrink. As you can see, it's a little bit trickier because that 3 does not really mean times 3. It actually means times 1/3, the opposite of times 3. So if you actually want to see stretch, horizontally, you either have 1/3 times x, which means the same thing as x divided by 3. We know it's happening inside the square root, inside the parentheses there. So we know it's a horizontal. That means horizontal. We know it's a dilation because we're not adding or subtracting. We know it's not translation because we're not adding or subtracting, but it's definitely a dilation of some sort. So the only question is it stretch or shrink? Once again, if we're inside the parentheses, we got to do the opposite. So what's the opposite of multiplying by 1/3 or dividing by 3? The opposite is to multiply by 3. And since 3 is bigger than 1, that is a stretch by 3. Now we can do some combination here now. So let's do f of x, the original parent function, is x squared. And now let me do 3x squared. Now, right here, there's always a lot of confusion whether if you don't know your order of operations. Is 3 being squared? Or is only x being squared? Now, you need to understand where the parentheses is, and the only thing that's being squared here is just x. 3 is not being squared at all. So to emphasize where the parentheses right now, it is right here, and it is right here. So 3 is outside the parentheses, and we're multiplying by 3. So that means we have this 3 right here. You know, it's a dilation outside. So if outside means vertical, and it's straightforward. So by 3, it doesn't change. And 3 is bigger than 1, so we know that is a stretch by 3. Vertical stretch by 3. So let's try another one. If you want to see that inside, here's an example of inside. 5. Oh, let's do a example here. Oh, look at this one right here. Now this clearly, 5/4 is clearly inside the parentheses, and as you can see, it's inside, so we know this is horizontal because we are inside the parentheses. Now we gotta figure out if it's stretch or shrink. Now 5/4, remember if you're inside, you gotta think of the opposite. The opposite of multiplying by 5/4 is multiplying by the reciprocal 4/5. 4/5 is between 0 and 1. It's definitely less than 1. So if it's less than 1, it actually shrinks. Now I gave this example because some of you might think that a fraction always means shrink. So this is shrink, so the opposite is stretch. That's not how it works. This better make sure you check the value of the number, and don't just assume that fractions always shrinks. It's always smaller than 1. And the last transformation we have to talk about, because it causes confusion, is reflection. Now, here is the x-axis, and when you reflect over x-axis, you need to understand that it's a vertical change. As you can see right here, if you have something above and you reflect over the x, it's now below. If it's below when you reflect over the x-axis, it is now above. It's a vertical movement. It's a vertical change. And as by now, you hopefully understand, a vertical change happens when there's something changing outside the parentheses. Now you specifically notice a reflection if you're multiplying by a negative number. So as an example, let me take the function x squared. Let me multiply by negative 1. So, as you can see, here's the parentheses. And once again, you're not squaring the negative sign there. It is still outside. This is outside the parentheses, so it's a vertical change. And that's how you know you have a reflection over the x-axis. Even if I put a number here in front, that's negative 2x squared. Once again, the 2 has nothing to do with reflection. The negative sign lets you know you have a reflection over the x-axis. Once again, that negative is multiplying, and that's why you have a vertical change, because it's outside. Now, if you want to see a reflection over the y-axis, a horizontal change, and here's a visual example of the y-axis. If you reflect over the y-axis, as you can see, what's on the left side will end up on the right side. It's horizontal change. Okay, so when you reflect over the y-axis, it's horizontal. So reflect over y-axis, it's a horizontal change. And by now you hopefully understand a horizontal change means something is changing inside the parentheses. So you know you have a reflection if you're multiplying by a negative sign. So we just need to multiply the inside by a negative sign. So an example would be inside the parentheses squared. Another example would be square root of negative x. As you can see, the negative is inside the parentheses. These are all reflection over the y-axis. It does not matter if I put a 2, a 3, a 4 there, it does not matter. You're multiplying by a negative sign inside the parentheses. And once again, here's the parentheses. Then that's how you know you're reflecting over the y-axis. The 2 here, you're multiplying the x by a 2. Since you're multiplying by a number, that's a dilation. Your inside is a horizontal dilation. So I know it's a horizontal dilation, it means two things. This right here is reflect over y-axis, and the 2 that you're multiplying by means you have a horizontal dilation. So horizontal. Now, by how much? Remember, if you're inside the parentheses, you guys flip it, because it's the opposite of multiplying by 2. It's multiplying by half, and that's actually less than 1, and between 0 and 1, so we know that is a current. So there's actually two transformations going on here. And that's it for today.